Good day, everyone. It's Mr. Anderson here. I'm going to hook you up with some notes on section 13.3. Our goal today is to talk about a couple things, specifically a couple things that are going to help us broaden our understanding of some of these trig concepts. We're going to talk about a unit circle. We're going to use that as a bit of help, a visual representation of some larger angles. We use a reference angle at the same time to help connect to something we already know. But our goal is ultimately to broaden our understanding of some of these trig concepts to angles that are in between, larger than 90 degrees. We spent some time on SOHCAHTOA, right? Right triangle trig that is dealing with angles in between 0 and 90, but now today we're going to make that a little bit bigger. Okay. Our general definitions of some key trig concepts. These are essentially the same thing as SOHCAHTOA, except we use that unit circle, or well, it doesn't have to be a unit circle in this case, a circle with radius r, to define them, okay? The sine is still the opposite side over the hypotenuse, cosine is still adjacent over hypotenuse, and tangent is still opposite over adjacent, with, again, just a tiny reminder here that your denominator can't be 0, okay? On the next page, on page 10 of your notes, we see an example, and that example, example number 1 says, hey, let negative 12, 5 be a point on the terminal side of an angle theta, okay? So let's talk about what's going on here. So here's our picture, okay? And what we're going to go ahead and do is we're going to say there's theta, that's the angle we're going to goof around with here. This they're calling the terminal side because it's where theta terminates. So theta starts here and it goes to there. Okay? It says evaluate the trig functions of theta. We're just going to go ahead and evaluate sine, cosine, and tangent of theta, okay? So first and foremost, it's good to use a little bit of Pythagorean theorem. All right, I'm going to just draw this triangle in. Some of you might also like to transfer that triangle down here. I'm not sure what your preference is, but using that information and the fact that the scale on the x-axis is 4, we can call this side 12. We can call this side, this vertical measurement, 5. And then that Pythagorean theorem, if I set up 5 squared, I'm sorry, this is a right triangle because I'm using vertical and horizontal. If I set up 5 squared and 12 squared equals r squared, r is the radius of that circle that I would create if I took 360-degree navigation. I'd work this out. I get 25 and 144. Whoops. Let's erase that. I got to try that again. 25 and 144, and that would be r squared. Add those up, they make 169. I take the square root and I get 13. So that just tells me that the radius there is going to be 13. Now, what does that do for me? Well, let's consider this idea of a reference angle. Okay? I'm going to go ahead and put theta in there, and then I'll use this connection to opposite, adjacent, and hypotenuse to do the evaluating. Now, on the previous page, on page 9, we said sine is going to be y over r, or opposite over hypotenuse. So that tells me 5 over 13. Cosine, again on the previous page in that key concept box in the bottom, x over r. Well, x is the distance along the x-axis, 12, radius is 13, 12 over 13. And then tangent in this case is going to be opposite over adjacent, which in this case, I'm sorry, ladies and gentlemen, I made a mistake here. This is going to be a movement in the negative direction, negative 12 over 13. Sorry about that. And then tangent is going to be I apologize again. Now I erased too much. Negative 5 over 12, and you could really say that that's 5 over negative 12, but I chose to write the negative in the denominator there. All right? just evaluating those three trig ratios at that specific angle, okay? A checkpoint here has you doing something very similar. It says, hey, 6, -8 is on a terminal side of angle theta in standard position. Come up with those. We're not going to do all 6. We're just going to do the 3 trig functions. So what I would do here is I do my best to figure out where 6, -8 was. So let's see, it's count by 2s. That'll be 2, 4, 6. This will be -2, 4, 6, -8. So -2, -4, -6, -8. And if I'm going to go ahead and draw an angle, it's going to go to over 6 down 8. That'll be the terminal side. All right, and I guess to be totally honest, I'm only concerned about, oops, let's draw this in blue. I'm only concerned about that being that side of the triangle. So here we go. Start here, rotate around, and that right there is going to be my theta. So now I'll set up the sine of theta, and remember that here I've made a triangle. This side is going to be 6 units. This side is going to be 8 units. So then a little Pythagorean theorem, I can say 6 squared plus 8 squared equals r squared. If I work this out, this is a 3, 4, 5 right triangle. R happens to be 10. Well then, theta, sine of theta, excuse me, is the opposite over the hypotenuse, -8 over 10. And if you want, you can reduce that. Cosine of theta is going to be 6 adjacent over hypotenuse, which is 6 over 10. Again, we can reduce to 3/5. And then lastly, the tangent is going to be -8 over 6, opposite over adjacent, which is -4/3. All right. On the next page, let's see, this is going to be page 11, you have a lot of the same ideas present, but using a unit circle just means your radius in this case is 1. All right, we have our equation of a circle in the box. They call it a unit circle because our radius is exactly 1 unit. What else? Use the unit circle to evaluate. In example number 2, some trig functions here. Let's see. I have an angle of 450 degrees. So this is going to be the first time we've seen an angle this big. So here's how this is going to work. We're going to start, and I like to do it like this. 0 and 90. 90 more would make this 180. 90 more would make that 270. And 90 more would make this 360. Now check this out. That means a 450 degree angle is going to be more than 1 full revolution. Well, how much more? If I go 90 more, that's that 450 degree marker. So it's saying start here on the x-axis, rotate 1 full revolution, that's 360 degrees, but then 90 more and terminate right here. All right, if you back up and you read the definition of a quadrantal angle, it'll give you that. Okay, so then this is a full revolution of 360 and another 90 degrees. So we're going to end right there on that that y-axis above the x-axis there, and we can come up with those 3 trig functions that we care about: the sine, the cosine, and the tangent. Now that's going to be sine, cosine, and tangent of theta. Theta in this case is 450, so we'll call it the sine of 450, the cosine of 450, and the tangent of 450. All right, here's the key: the sine of 450, cosine of 450, and tangent of 450, these 3 things, because 450 is only 90 degrees more than 360, are also going to be the same as the sine of 90, the cosine of 90, and the tangent of 90. All right, and if you work these out, the sine of 90 via calculator is 1, the cosine of 90 via calculator or otherwise is 0, and then the tangent of 90 works out to be undefined. Now why? Because if you remember, tangent is equal to sine over cosine, and if cosine 0 is on the bottom, we we can't divide by 0. We get an undefined measurement. All right, let's keep cruising into page 11 here, my dears. On page 11, you're going to see some reference angle relationships. Here's the key. Go ahead and read this key concept box, but know, and you're going to see me do it in a second, know that I always try to draw a reference angle so that you're terminating on the nearest x-axis. So check this out. This little green piece here represents the reference angle. So if theta is my angle, then theta prime works out to be the reference angle. That's how we denote that, okay? And you're always just trying to terminate on the nearest x-axis, okay? So it says in this particular problem here, in example number 3, it says find the reference angle theta prime for A, 300 degrees, and B, negative 130 degrees. Well, let's do A right here, okay? Pretty straightforward problem. It's helpful to draw a picture. All right. I'm going to draw a angle of 300 degrees. Now, an angle of 300 degrees is about 60 degrees short of a full, well, it's exactly 60 degrees short of a full revolution. So there's 300 degrees. That would be theta. Now, we're trying to terminate on the nearest x-axis, and the nearest x-axis is going to be right here. That's going to be theta prime. So the question I'm asking myself is, that would be one full revolution, but I didn't go all the way. I only went 300 degrees. Theta prime works out to be 60 degrees. All right? Over here, on the second part of the problem, they say, hey, work this out, but this time let the angle of rotation be negative 130 degrees. Some of us may have never seen this before. That means start here at 0 and work backwards. More than 90, in fact, 40 degrees more than 90. You're going to stop right there. That'll be negative 130. Now, I again like to go to the nearest x-axis. Nearest x-axis is going to be to continue that way. If this is theta, then this is theta prime. But how big is that? Well, if I went a full half rotation over here, that would be negative 180 degrees. But, oops, I did not go the full 180, I only went 130. That means my reference angle is 50 degrees, or my theta prime is 50 degrees. All right, one last idea that I want to connect on before we're done with the video here, and I'm going to be out of time pretty quick, is this. These are the trig functions we have, where they're positive in which quadrant, okay? I like to remember ASTC. And it's the expression, all seniors turn crazy. All right? And the A represents all trig functions being true in the first quadrant. The S represents the sign being positive. Did I say true? I meant positive. I'm sorry. The sign being positive in the second quadrant. T represents tangent being positive in the third quadrant. And finally, C represents cosine being positive in the fourth quadrant. Ladies and gentlemen, that's going to be it for this video. That's all we're making it through. Well, in our 15 minutes here. I will be back on Monday. You can ask questions on Monday, but go ahead and give that homework a shot, and solutions are posted on Schoology. If the homework's going okay, then give the quiz a shot. As always, you can shoot me an email with questions. I do try to get back to that pretty regularly. Thanks. Have a great day.